Section 12.5, volumes of pyramids and cones. Our two formulas there. The volume of a pyramid is going to be 1/3 the area of your base times the height. Again, the same area for a cone, but a cone is going to have a base of a circle. So we're going to have 1/3 pi r squared h, because pi r squared is just the area of our base. Again, here you can see it visually. Again, cones and pyramids, whether they're oblique or just right pyramids and cones, will have the same formula, just that 1/3 area of the base times the height. Alright, so here we're asked to find the volume of a square pyramid. Area of the base, we see the base is a square. Area of the base is just going to be 3 squared then, so that's going to be 9 times our height, which is 7. Multiply that by 1/3. So we're going to get 1/3 of 63, which is going to be approximately 21 when we multiply. So we're going to have 21 cubic inches. Again, they gave us inches as our unit. So with volumes, we always have our unit to the third power. Here we're asked to find the volume of our pyramid here. We see a hexagonal pyramid, so we know that pyramid is broken down into 6 equilateral triangles. So to find the area of the base, we're just going to take our regular 1/4 times side squared times the square root of 3 formula to find the area of our triangles. So that base is going to be 6 times 1/4 times 2 squared, which is 4. So that's really just going to be the square root of 3. So we're going to have 6 square roots of 3 for a base. We multiply that by 1/3 and by our height. So we're going to have 30 square roots of 3 times 1/3, which would just be 10 square roots of 3, or approximately 17.3 units cubed for the volume of our pyramid. Here, Brad is building a model pyramid for a social studies project. The model is a square pyramid with a base edge of 8 feet, and a height is 6.5. Find the volume of the pyramid. So we know our volume formula, 1/3 area of the base times the height. Area of our base, since our base is square, is just going to be 8 squared, or 8 times 8, times our height. And we always take 1/3 of that. So we're going to get 64 times 6.5 times 1/3. And our answer then should be 138 2/3 feet cubed, or 138.6667. Again, feet cubed because we've got a unit of feet. Alright, here we're trying to find the volume of this cone to the nearest tenth. We know the volume of a cone is still 1/3 area of the base times the height. Area of a circle, though, is just going to be pi r squared. So we have 1/3 times pi r squared times h. So we got 1/3 times 5 squared times 12. 5 squared is going to be 25. Times 12 is going to give us 300. Times 1/3 is going to give us 100 pi, which is approximately 314.2. Again, that'd be inches cubed for units on there, or cubic inches. Alright, here we're asked to find the volume of this cone to the nearest tenth. So again, we know volume is going to be 1/3 pi r squared h. So our volume is going to equal 1/3 times pi times our radius squared, so 8 squared is going to be 64, times 15. So we're going to end up with, we multiply that out, 320 pi, which is going to be approximately 1005.3. Again, meters cubed, because our unit is meters. Here we can use a given volume to find either the radius or the height. Here we're asked to find the radius given a height. So we know our volume is 2,262. So we're going to set 2,262 equal to 1/3 pi r squared times 15. So when we multiply 1/3 by 15, that's going to give us a 5. So we'll have 2,262 times 5 pi r squared. To get r squared alone, we divide both sides by, I guess here we multiplied by 3 to get rid of the 1/3, divided by 15, and then we're going to have to divide by pi. So really, what you could have done is multiply the 1/3 by 15 to get 5. 5 pi times r squared is going to equal 2,262. Divide both sides by 5 pi. Either way works. We take the square root of both sides, and we're going to end up with a radius of approximately 12. Alright, here we're trying to find the volume of a nautical prism, meaning we have a pyramid on top of a prism. So we need to add the volume of the pyramid plus the volume of the prism. So we know for the volume of the pyramid, we're going to take 1/3 times the area of the base times the height. Our height of the pyramid is going to be 6. Height of that prism there they give us is 0.5. We've got a base length of 8 for that hexagon. So since it's a hexagon, we know the volume, the area of our base is going to be equal to 6 times each one of our equilateral triangles. So 6 times 1/4 times our side squared times the square root of 3. So the area of our base is going to end up being 6 times 1/4 times 8 squared times the square root of 3. We know 8 squared is just going to be 64. 1/4 of that would be 16. So it's going to be 96 square roots of 3 for the area of our base. So we plug that in to each of our different formulas. We're going to have 1/3 times 96 square roots of 3 times 6 to find the area of the pyramid. We're going to add on the area of our rectangular prism, which is just going to be the area of the base times the height, so 96 square roots of 3 times 0.5. And when we plug that into our calculators and multiply, we're going to get approximately 4,156.92 units cubed. That's all we have for section 12.5. Blogs due tomorrow. Start working on those homework checks. Have a wonderful night.